Good morning and welcome to part 2 in Skyline Software Systems Virtual Trade Show webinar series. My name is Catherine Ryan and I will be your host for today's webinar. As always, please submit your questions in the questions area on your GoToWebinar dashboard and they'll be answered as they come or at the end of the broadcast. Every attendee will receive a link to the video of this webinar later today, so please look for that email. Thank you so much for tuning in and let's get started. Today, we are taking a deep dive into TerraExplorer with my friend and coworker, Itai Ben-Schechter, the Director of Production Sales and Services here at Skyline. Hi, Itai, how are you?
How you doing? I'm doing great.
Thank you so much for being here. Let's start at the beginning. In the simplest way possible, can you describe what TerraExplorer is and what it does? And we can get more technical later, but let's start super easy explanation.
Sure. So TerraExplorer is a full 3D visualization, analytics, and dissemination tool. It allows to bring in a lot of different data sources and different formats from different locations and bring them into one cohesive view where everything can be then analyzed, simulated, and presented in a way that leverages all the different data sources in one location. So it's been a very successful tool in over 20 years. And in the last couple of years, given the rise of 3D meshes and textured 3D, we've added a lot of support and capabilities and different tools that are specifically designated to address those different mesh formats and make them ingestible in TerraExplorer and very usable.
Interesting. So what's the difference between TerraExplorer Desktop, TerraExplorer for web, and TerraExplorer for mobile?
So TerraExplorer Desktop is our full tool that can be installed on a laptop or a desktop, a standard computer. It has the full range of capabilities and can leverage all of the different tools that are available in the full suite. It also includes an API, which allows to customize and build your own tools and extensions on top of the TerraExplorer 3D engine. And the web version is a thin client that runs on any browser. And it utilizes data that is being streamed in, usually from the Skyline globe, but not exclusively. So you could also bring in data from other servers into the TerraExplorer for web. It's developed on a lot of the cesium capabilities with our own extensions on top and our own modifications, additions, enhancements. The TerraExplorer Mobile is an app-based software that runs on Android phones and iOS to support being able to take the data off of the desktop product and into the mobile for use in the field, and having the capability to have it in a handheld device.
Wow, that's amazing. So can you talk a little bit about who uses the TerraExplorer package or what industries might benefit from this technology?
Yeah, so there's a lot of companies that utilize the software in order to consolidate a lot of their different data sources and then be able to utilize them collaboratively between offices that are in different parts of the world or different parts of the country. So that is enhanced with the Skyline Globe server capabilities. People can work on data in different locations, but essentially enhance the same project. This includes companies that do city planning. We support a lot of municipalities, counties, different cities in the world. And we also utilizing, let's say, construction projects and monitoring them in 3D over time. TerraExplorer also has a time signature that can be associated so that you can view things over the course of a period of time. And also damage assessment and emergency response, the ability to visualize the results in 3D, mark them, make measurements on top of them, and also a lot of use in DoD and mission planning, command and control, and any sort of operational activities that 3D could definitely be a very useful tool for in doing line of sight analysis or analyzing visibility from paths or different locations in highly urban environments or difficult terrain, hilly environments. So that's a lot of the different applications that the software gets used for.
And what kind of training do end users need to be able to adequately use TerraExplorer?
So the training, we have a very extensive user guide, and we also have a lot of videos and tutorials on our YouTube page, and we constantly add more whenever there's new features. So even the things I'm going to show today are well covered in our YouTube videos. We also offer online training and also on-site training. I would say that depending on the user's existing understanding and knowledge of GIS formats, layers, and workflows, they can pick up the software in a couple of hours. If not, then we're always available to support them and get them scaled up on being fully operational with the tool.
Got it. Now, before we jump into looking at the software, are there any tips and tricks you would want potential users to know or use? Is that something you can show us?
Yeah, so one of the things that I think are becoming a lot more apparent given the availability of 3D data sets from many different sources. So similar to the paradigm that we adapted to in being able to support, let's say, vector layers or polygonal layers, they could be coming from a GIS environment such as Esri and shapefiles or geodatabase. They could be coming from CAD environments or from any sort of engineering platforms. So, or they could be just coming from databases like SQLite. So we've made the software compatible with all those different formats. This is the similar paradigm of being able to support 3D meshes and textured meshes from a lot of different formats and sources, be able to integrate them into the software and then use them freely with really good performance, and all of the available tools that are already in TerraExplorer becoming available to the 3D mesh layers that are imported or streamed in. So that's the main, I think, takeaway is that whatever data source or wherever you got the mesh layer that you're looking to bring into the software, we can make it work and we can help you optimize it to, once again, make TerraExplorer the central tool for the analysis, the measurement, dissemination of the data.
Excellent. Now, I want to talk about something you mentioned earlier, the customization. And one of the first things that impressed me so much about TerraExplorer when I first saw it was the just seemingly limitless possibilities in terms of applications and uses. And I hope I'm describing this correctly, but the ability to overlay information from maybe a third-party source and integrate it with data that the user already has. For example, adding data from an insurance company over top a 3D model of a neighborhood damaged by a hurricane or a tornado, and ending up with an interactive 3D model that shows, the physical damage level of homes as well as maybe insurance status or homeowner information or contact information. Can you talk a little bit more about that?
Yeah, so that's one of the capabilities that allow integration of sources. So let's say if there's an available layer for building IDs or census information, it could be overlaid on top of the 3D data. And then the 3D data is more than just a visual layer, it becomes an informative layer. And I'll show how that could also be embedded into the 3D layer. So we have the ability to include attributional information. That's part of the 3D layer itself, and then make it queryable. So if you see a house, you can just click it and then get the information on that house. So it's all becoming a part of the 3D database in the mesh.
Excellent.
So that's also in the new capabilities that we're continuing to enhance.
Excellent. So what's the next big thing for TerraExplorer?
So the next big thing that we're working on is going to be making the classification of the mesh, or the ability to embed attribute information in the mesh, dynamic. So instead of having to create a new mesh, the mesh could be then segmented or colorized based on a layer in the project. And if that layer is being streamed in, if that layer gets updated, then the mesh gets updated dynamically. So that's makes it even more useful for being able to do cadastral information, census information that might get updated every couple of months. And also for areas that are going under construction, or new neighborhoods, or even in operational settings, where let's say you're monitoring cars, and you're saying, okay, here are the car locations, and then they could be a layer on top of the mesh or inside the mesh that can be queried and displayed differently. So those are some of the directions that TerraExplorer is going into. And also, I think there's a lot more in point cloud visualization and streaming that we're working on. I'll cover that a little bit as well. So being able to have also different point cloud sources and being able to display their classes along with the mesh is going to be another direction that we're continuing to enhance the software. And then also on our processing side with PhotoMesh, but definitely in TerraExplorer with visualization and analytics on top of point clouds.
Excellent. So what are you going to show us on the software?
So I'll go over real quick the different ability to load meshes and convert them, or to stream them in. So one of the available files, 3D tiles, the cesium layer, if you have it as a URL, it could be just loaded in. And you see, this is the location of the file. It's still in a 3D tile format, and it's called a tileset.json. And I'm bringing the layer in here, and it has all of the built-in pyramids and the ability to visualize and analyze on top of that. So that's one thing that is currently already available in 7.2. The other option that is possible is to bring in the mesh and then convert it to a 3D ML, so that then you can also publish it to the globe and you can classify it. So I'll go over one of the options that we have, and then while it's running, I'll explain a little bit how to set that up. So let's say OSGB layer, which is a very popular layer. There's a lot of times it comes out in tiles, different tiles, and those tiles might have internal pyramids and texture files for the tile itself. So we allow you to create what we call a file list.txt, and I'll load that in. Then you can define the coordinate system that the data is in, and where you want to export it to. So let me export that while it's running, and I'll go over what that file list is and how it's configured. Just a second, just create a new folder here. There we go. And let's create it. So I'll show you the layers that we're working on. So this is the OSGB. The file list itself contains the root OSGB and each one of the directories that it's in. So even if you have, hundreds of different tiles, that single file is able to then consolidate them all into a single layer, just using this list. And this list is in the relative location inside where these tiles are. So that's how you could then produce a 3DML from OSGB layer that might be tiled. There usually are tiled. So creating this file list that we see here is how the OSGB layers can be brought in. For 3D tile set, I'll go over the 3D tiles, the cesium tiles. This tile set contains usually the information of all of the tiles. It's called the tileset.json. That's the standard format for it. So using this file, which has the volume or bounding box and some other information on the layer, the geometric air and the pyramids themselves or the tiles contain the information for when to visualize each one of the levels of detail. All that needs to be done is just have this file referenced, and then it produces a 3DML from all these tiles combined. So that's for the 3D tiles and for the OSGB. The third one that we cover is Lod Tree Export, and that's an XML file that works similar in the way that it references all of the subdirectories, and then they can be then imported and converted to the 3DML. So it's going to finish in a second, and I'll load it into the software, and then, oh, there we go, we just finished. And then we can load in the different options for 3DML once it's complete. The message came up on the screen. Here we go, successful. And it's been added to the project. So here it is. And this is the file, the OSGB based that we converted to a 3DML. So one of the capabilities, you can see we added a 3D mesh layer tab. So all of these capabilities are now available once the file has been converted to a 3DML. One of them is the ability to, let's say, if you had a CAD model, or if you had, in some cases, there's low resolution, large scale meshes, and then you want to add a high resolution mesh. So let's say it was captured by a UAV or a lower altitude, high resolution flight. So you can always modify the mesh layer. And then you can draw the area that you want to have flattened out. Let's say this is the building that we want to flatten out. And that's it. And then this building is then flattened, and another building can be placed on top. So that's all the capability. Some of the capabilities are available on top of the 3DML layer. The other one that I'll go over is if you have, let's say, a polygonal layer with information, with attribute information. So in this case, we have different classification of the structures in this data set. So if we look at, let's say, one of these, we could see the attributes and the name. Over here, I think there's the horn, and this is on top of the ortho. So if you have the 3DML available, you could then bring in highlight the layer, and then you have a classify mesh layer option. You could then select, and you can select multiple shapefiles. So let's say if you have one shapefile of buildings, another shapefile of roads, another shapefile that represents vegetation, or let's say different types of buildings, public buildings, private buildings, commercial buildings. You could check all of them, and then you create a new 3DML that has the classes built in. So this is the classified 3DML. It looks exactly the same. The main difference is I can select features and query them if I wanted to. See, so when I hover over the structure, it highlights. If I click on it, it loads all the information that was available in the layer. The other option is also to do any sort of querying. So let's say, see if I select the structures and I want to do a query on an area. So I want to see which structures are inside this polygon. They automatically get highlighted and they also appear in the attribute table. So the 3DML essentially becomes a fully informational layer and not just a visual layer. The ability to then tap into GIS databases, any sort of available information. So that is some of the capabilities that 3DML allows. We've also added the different display styles and display tools, such as being able to visualize the wireframe. And another one that is very useful is X-ray mode. So let's say if you have indoor information, you can see inside of the layer, the 3D layer, and then look inside the building. You can also place yourself inside the building, but the X-ray allows you to interact with both the outside and the inside, or be able to view underground information at the same time. So those are some of the available 3DML functions. The other one that I'll cover before I move to point clouds is if you have a 3DML layer, you can also export it. So once it's inside the software, you load in the 3DML, and then you can export it to 3D tiles, cesium, or also to I3S SLPK, the Esri. And then be able to utilize them in other software. I see I'm getting some questions, and I'll address them a little bit towards the end. There's a question on the classified 3DML and TE for web. So that is partially integrated, not fully. And I think in the next release of Skyline Globe, which is also the T for web capability, it'll be better integrated. Right now, the desktop better supports the querying because it has more querying tools and measurement tools, and which apply specifically for the classified mesh. So it's not 100% in the web version yet, but it's going to be there. One more thing is that once the 3DML is classified, the layers themselves are subclasses in the mesh layer. So you can see I could just turn off different layers, or let's say leave just the buildings. So that's the capabilities that are embedded once a mesh layer is in the software. There's also an ability to export individual areas based on a feature layer, or you can draw. And if you have classification, you can also export by classification features. So, you know, I could export the building structures, or I can also, let's say if I wanted to export just a single model, that would be by draw and export a single model. So I can draw it, and then it would cut out this and export it to an OBJ in this case. So those are the export capabilities that are available in TerraExplorer. Just a quick note before I jump to the point cloud. We've developed a whole executable and functionalities for mesh conversion. These are just the ones that are in the GUI, but we have a lot more capabilities that are accessible if they want to be tapped into with the API, or if you want us to support you using command line interface. So we can also bring in or convert 3DML to 3MX layers. And we have other formats that we can ingest and convert that are not fully integrated in the GUI yet, but we do have the ability to support them. So that's it for mesh layers. Now I'll jump into the point cloud capabilities for a couple of minutes. So one of the things that now are supported, and turn off the background layer of the mesh, is that a point cloud layer, an LAS file, if it contains classification information, we're able to include all of those classes in conversion to our CPT format, which is a streamable format. And we can see over here I'm colorizing the points based on classification, and these are the colors I chose. Gray, dark gray, and light gray is ground or unclassified. Orange is low to medium vegetation. Green is high vegetation, and brown is buildings. Now you can see that you're not seeing any orange, so I have the choice of whether to include the points and make them visible or not. So you see, I'm not visualizing the medium or low vegetation. In this case, medium and low vegetation usually represents cars. So you'll see that there's really no cars in this point cloud. That's why there's all these gaps here. But if I did want to visualize them, I can go and in the point visibility options, then select to visualize the low and medium vegetation in this case, and then apply it, and you'll be able to see now all the orange pop in, the low and medium vegetation option. Another very nice feature that is now available, I can copy the layer style. So let's say if you have several point clouds, and let's remove this for a second in the visibility, and then we'll apply it to the other one and see how it works. So apply it, and then I'll copy the layer style. Now this is another LAS layer. They could all be merged into one CPT when they're brought in. In this case, for the demonstration, I kept them as two separate layers. So this one still has the low and medium vegetation being displayed. And I can paste the layer style in here. I got a question, does copying layer style work only for CPT layers? No. So now it's available on also polygon layers, GIS layers, really anything that you'd like to see. So this is a vector layer. You can copy the layer style and then paste it to other layers. So the copy and paste layer properties is not just in the CPT, it's in our feature layers as well. You can see over here that the point cloud with only ground, building, and vegetation displayed. The other thing that's nice is being able to show the intensity blend. So the intensity is included in the LiDAR. If I show 100% of the intensity, you'll just see the LiDAR displayed in intensity values. So it's like this. The intensity blend, though, gives a little bit of information because of the returns that see features, like you can see road markings or colors of houses or vegetation. If the intensity blend is set to 0, it'll look just like a colorized point cloud with only the colors representing features. But if you put an intensity blend, just for demonstration, let's say I'll put 50, it'll blend in 50% of the intensity layer and 50% of the point cloud classification color. So that's how it looks like at 50%. I find that it's a lot more informative. Let's say you're seeing that the information here, even though it's all ground, if I remove the intensity blend, it's a lot harder to understand what you're looking at in terms of this field. With it, we know that it's a baseball field. You can also see where the crossroads are, intersections. So that's much more enhanced visualization features for the point cloud display.
That
So
is beautiful. Itai, we're at about 11:30.
yeah,
Do we want to see if anyone else has got questions? Are there any questions that can be answered that came up while you were speaking?
yeah, I addressed them as they came in. The only one minor thing I wanted to add before we can close it out, and anybody feel free to ask questions if they're still coming up. We have the integration with the Oculus Rift VR and the new generation one, the Rift S, and that is also comes with the API for controllers. So you can sort of customize what the buttons in the controllers do, and then be able to utilize everything that you're seeing inside the TerraExplorer screen in the VR goggles and do fly-throughs or any sort of virtual reality simulation presentations using the VR integration. So I just
That's
wanted to cover that point. I think that's it.
wonderful. That is all the time that we've got for today. Thank you for Itai for a very informative and interesting session. I learned a lot. I'm sure everybody else did too. Every attendee will receive an email that's got links to our YouTube channel and our social media, as well as a link to the video from this webinar. So please look for that in your inbox and stay safe and have a great day. Thank you so much for joining.
Thanks, everyone. Bye.